Welcome to today's ArXiv CS Digest for March 10, 2026. We received 771 new computer science papers today across 63 subfields. Let's dive into the top picks. Up next, our first paper out of 5, a prospective clinical feasibility study of a conversational diagnostic AI in an ambulatory primary care clinic by Peter Brodeur and Anil Polepoo from Beth Israel Deaconess Medical Center. Let's break down its key contributions. Artificial intelligence, particularly large language models, holds immense potential for revolutionizing patient care, from diagnostics to management. However, before these systems can be widely adopted, it's crucial to evaluate their performance, safety, and user experience in actual clinical environments, moving beyond controlled simulations. This paper addresses that critical need by bringing a conversational AI into a real-world primary care clinic. This was a prospective, single-arm feasibility study. Researchers enrolled 100 adult patients who were scheduled for urgent care appointments. Each patient interacted with Amy, an LLM-based conversational AI, which took their clinical history and presented potential diagnoses. Human safety supervisors monitored all interactions in real time. The study then compared Amy's diagnostic capabilities and management plans against those of primary care providers, and assessed patient and clinician satisfaction. The results were quite promising. Crucially, human safety supervisors did not need to intervene in any of the 100 patient-Amy interactions, indicating a high level of safety. Patients reported high satisfaction, and their attitudes towards AI significantly improved after using Amy, with a p-value less than 0.001. Amy's differential diagnosis included the final diagnosis in 90% of cases, achieving 75% accuracy within its top 3 diagnoses. When compared to primary care providers, Amy showed similar overall quality for differential diagnoses and management plans, with no significant differences in appropriateness or safety. However, PCPs did outperform Amy in the practicality and cost-effectiveness of management plans. This study marks a significant milestone, demonstrating that conversational AI can be safely and effectively integrated into real-world primary care workflows, with high patient and clinician acceptance. While Amy showed strong diagnostic capabilities, comparable to human providers, it's important to note that PCPs still had an edge in the practicality and cost-effectiveness of their management plans. This initial feasibility study is a vital step towards broader clinical translation, but it also highlights areas for future development, particularly in refining AI's ability to generate more practical and cost-efficient care strategies. Up next, our second paper out of 5, PRECEPT, Planning Resilience via Experience, Context Engineering and Probing Trajectories, a unified framework for test time adaptation with compositional rule learning and Pareto-Guided prompt evolution by Arash Shamansori. Let's break down its key contributions. This component ensures precise rule application through deterministic exact match retrieval over structured condition keys. It eliminates partial match interpretation errors and supports compositional stacking via a semantic tier hierarchy. This memory system incorporates Bayesian source reliability and threshold-based rule invalidation. It actively resolves conflicts between static and dynamic knowledge, enabling effective adaptation to environmental drift. Compass is a Pareto-guided prompt evolution outer loop that systematically evaluates and refines prompts. It uses the same end-to-end execution pipeline for evaluation, ensuring robust and optimized prompt generation. Up next, our third paper out of 5, an empirical study and theoretical explanation on task-level model merging collapse by Yuan Chao and Tao Xie from Peking University. Let's break down its key contributions. The study empirically demonstrates a strong correlation between representational incompatibility among tasks and the occurrence of merging collapse. This challenges prior assumptions about parameter space conflicts being the primary cause. A novel theoretical explanation for merging collapse is provided using rate distortion theory. This framework establishes fundamental limits on task mergeability, offering a dimension-dependent bound on the phenomenon. Up next, our fourth paper out of 5, Exclusive Self-Attention by Shuangfei Zhai from Apple. Let's break down its key contributions. Transformers exhibit an attention similarity bias where attention output highly correlates with the self-value vector. This wastes SA capacity on point-wise features, hindering effective contextual modeling and motivating our solution. Exclusive self-attention, XSA, modifies standard self-attention by explicitly constraining its output to be orthogonal to the token's own value vector. This encourages richer context modeling by excluding redundant self-position information. Up next, our fifth paper out of 5, Latent DRM, Bridging Discrete Diffusion and Autoregressive Models for Reasoning by Lina Bariana and Wei Chen from EPFL. Let's break down its key contributions. Integrates a discrete diffusion language model, DDLM, as a dedicated planner agent. This leverages DDLM's strengths in non-sequential, globally revisable generation for robust planning and complex reasoning tasks. Assigns an autoregressive language model, ARM, the role of an executor. The ARM translates DDLM plans into fluent, coherent text, effectively overcoming the DDLM's inherent limitations in text generation quality. Introduces a novel latent space communication mechanism to bridge the DDLM planner and ARM executor. This enables efficient, non-textual information exchange, facilitating seamless collaboration between heterogeneous models. Establishes a framework for effective collaboration between models with fundamentally different generation paradigms. This maximizes the benefits of both DDLMs for planning and ARMs for fluent execution, enhancing overall reasoning capabilities.